episode is on mutually exclusive events and the addition property. Thousands of pieces of data bombard us every day. We feel room temperature, see cars on the road, hear sounds of various types and magnitudes, log onto our computer to access communications we receive, and plan and organize our schedule for the day. Each time we make a neural connection, linking one idea, person, or message to another in our memory. We are constantly learning and constantly improving ourselves by determining probabilities subconsciously. In sports, athletes and coaches track wins and losses, scores, fouls, measurements, and both personal and team statistics. Whether it is football, baseball, basketball, soccer, track, lacrosse, tennis, skating, gymnastics, hockey, wrestling, or any other sport, statistics are tracked and probabilities are considered. For example, if you watch film of your opponent in order to prepare for an event, you may realize that they are more likely to run a certain pattern, hit a ball to a certain area, or pass to a certain person. Since most people are creatures of habit, these habits or probabilities of a given event should be considered before a match. The study of movement patterns, strategy, and tactics in team sports is called notational analysis. This includes the evaluation, comparison, and analysis of tactical and technical execution. Computer models are generated to predict both coach and athlete behaviors based on probabilities. Surveys can collect general data about attitudes and interests that are helpful in predicting and modeling outcomes. In a 2011 survey from Scarborough Sports Marketing, respondents were asked about the sports in which they were interested. Although baseball is considered America's sport, professional football came out far ahead. We have a rule to determine probabilities that states the probability of A or B equals the probability of A plus the probability of B. This is only true if events A and B are mutually exclusive. In other words, the two events have no common elements. In a Venn diagram depiction, the two circles are not connected because there's nothing in common. On the other hand, we cannot add the probability a person is interested in football and the probability a person is interested in baseball because they could be interested in both. The rule for this is the probability that a person likes football or baseball equals the probability they like football plus the probability they like baseball minus the probability they like football and baseball, which is counted twice. On a completely different topic, there's been much talk about our country's use of oil as an energy source and alternative energy options. Here is a graph of the percentages or probabilities of use of various types of energy used in 2008. Notice that while the use of petroleum P is the largest at 37%, we write P of P equals 0.37. The use of natural gas N is 0.24, and rewrite this as probability of N equals 0.24. And coal, P parentheses C, is 23%, or the probability of coal is 0.23. Combined, natural gas and coal add to more than 37%. In this case, since natural gas and coal are different with no common elements, they are mutually exclusive. So we can add those two probabilities. So the probability of natural gas and coal equals the probability of natural gas plus the probability of coal, which equals 0.24 plus 0.23, which equals 0.47. Many people talk about solar power and wind as being up-and-coming sources for energy. When you drive throughout the United States, you might see wind farms or solar panels on homes and office buildings. However, all of the renewable energy combined only add to 7%. While it may seem that solar energy S is 1% and wind energy W is 7% from the graph, look closer. Solar energy is only 1% of the 7% of the total pie slice. So the probability of solar energy, denoted by P of S, is the probability of solar energy, which equals 0.01 times 0.07, which equals 0.0007. Remember, of means to multiply, so the amount of solar energy used in the United States is 0.07%. Similarly, wind energy is 7% of the 7% of the pie, or the probability of wind equals 0.07 times 0.07, which equals 0.0049. These are mutually exclusive because solar and wind have no common elements. Thus, the probability of solar energy and wind energy equals the probability of solar energy plus the probability of wind energy, which is 0.0007 plus 0.0049, which equals 0.0056 or 0.56%. That means that as much as you hear in the news about solar and wind energy, the total of these two energy sources combined provide us only a little more than 0.5% of all of our U.S. consumed energy. Let's look at this topic with regards to social media. There are numerous types of social media. Analyzing the numbers and types of social media is a key part of target marketing to consumers. Who is online? What sites do they visit? How do they buy? How many connections do they have? Are they more likely to visit Facebook, Google+, LinkedIn, or Twitter? How often? If you have a limited budget to sell your product, what would you do, or where would you place your ad? What demographic is likely to buy your product? We need statistical data. Let's start with the definition of demographics so we're all on the same page. Demographics are quantifiable statistics from a given population characterizing subsets such as gender, age, ethnicity, employment, income, education, and mobility. Demographics are valuable in considering social, commercial, and political trends. Heavily used in marketing, demographics can tell who is more likely to purchase a product or use a certain brand. Census data portraying all people in the United States is collected every 10 years. Many organizations also survey groups to collect data. One group is called the Nielsen Group. In 2012, Nielsen social media report data shows that the use of the internet grew 21% from 2011 to 2012. Individuals aged 18 to 24 spent most of the time using social media, of all age groups. But those 25 to 34 spent the most time on mobile devices. Mobile web increased 82%, and mobile app use is up 85%. Social media is used on PCs 94% of the time, but tablets were used by 16% of the people. Facebook dominates social media at 17%. Females spend more time on social media than males. Pinterest grew 1,047% last year and is more used than Google+ and MySpace combined. People aged 25 to 34 are most likely to use social media in the office. Respondents said that they feel connected and informed when using social media, and 76% of the people felt positive after participating in social media. Dual screening, watching TV, and using a device is common, and nearly a quarter of those aged 18 to 34 use social media to comment on the storyline while watching TV. 1/3 of Twitter users tweeted about TV content. In early 2013, Facebook trumped the marketplace of social media, rising to nearly 1 billion unique visitors. Around the world, the use of Facebook is growing. Another important point is that data is outdated pretty much just after it is published, but it still serves as a starting place to consider demographics and the market. None of this probability analysis could be done without understanding mutually exclusive events and the addition property. As you continue to study probability and statistics, you will find tons of uses and become better at interpreting data. Well, that's all for this lesson.